Weekly Robot News. Hello viewers, welcome back to your one-stop shop for all news robotics. We're back once more with the latest, sometimes shocking happenings of the robotic tech world. So let's jump right into our weekly updates. However, before we do, we request you to subscribe to the channel and press the bell icon to never miss another upload of ours. Having said that, let's get right to it. Highlights of the week. Bone growth-inspired microrobots. Yes, they can create their own bone. Inspired by the growth of bones in the skeleton, researchers at the universities of Linköping in Sweden and Oyama in Japan have developed a combination of materials that can morph into various shapes before hardening. The material is initially soft, but later hardens through a bone development process that uses the same materials found in the skeleton. When we're born, we have gaps in our skulls that are covered by pieces of soft connective tissue called fontanelles. It's thanks to fontanelles that our skulls can be deformed during birth and pass successfully through the birth canal. Post-birth, the fontanelle tissue gradually changes to hard bone. Now, researchers have combined materials which together resemble this natural process, and hence come these microrobots. Mind-controlled robots. One step closer. Researchers teamed up to develop a machine learning program that can be connected to a human brain and used to command a robot. The program adjusts the robot's movements based on electrical signals from the brain. The hope is that with this invention, tetraplegic patients will be able to carry out more day-to-day activities on their own. Tetraplegic patients are prisoners of their own bodies, unable to speak or perform the slightest movement. Researchers have been working for years to develop systems that can help these patients carry out some tasks on their own, that prevent them from performing even the simplest tasks, such as grasping an object, says Professor Odd Billard, the head of EPFL's Learning Algorithms and Systems Laboratory. Assistance from robots could help these people recover some of their lost dexterity, since the robot can execute tasks in their place. Consciousness. Humans, animals, and artificial intelligence. A new theory of consciousness provides experimental access to the study of this phenomenon, not just in humans. Two researchers at Ruhr-Universität Bochum, RUB, have come up with a new theory of consciousness. They've long been exploring the nature of consciousness, the question of how and where the brain generates consciousness, and whether animals also have consciousness. The new concept describes consciousness as a state that's tied to complex cognitive operations, and not just as a passive basic state that automatically prevails when we're awake. The hypothesis underlying our platform theory of consciousness can be tested in experimental studies, as the authors describe one advantage of their concept over alternative models. Thus, the process of consciousness can be explored in humans and animals, or even in the context of artificial intelligence. AlienGo Quadruped welding a lightsaber. Unitary Robotics, well known for providing affordable legged robots alongside questionable Star Wars themed promotional videos, has announced a brand new, custom-made 6 degree of freedom robotic arm intended to be mounted on the back of its larger quadrupeds. Also, it will save humanity from Sith from Mars or something. A robot for the worst job. As COVID-19 stresses global supply chains, the logistics industry is looking to automation to help keep workers safe and boost their efficiency. But there are many warehouse operations that don't lend themselves to traditional automation, namely tasks where the inputs and outputs of a process aren't always well defined and can't be completely controlled. A new generation of robots with the intelligence and flexibility to handle the kind of variation that people take in stride is entering warehouse environments. A prime example is Stretch, a new robot from Boston Dynamics that can move heavy boxes where they need to go just as fast as an experienced warehouse worker. Stretch's design is somewhat of a departure from the humanoid and quadrupedal robots that Boston Dynamics is best known for, such as Atlas and Spot. With its single massive arm, a gripper packed with sensors, and an array of suction cups, and an omnidirectional mobile base, Stretch can transfer boxes that weigh as much as 50 pounds, 23 kilograms, from the back of a truck to a conveyor belt at a rate of 800 boxes per hour. An experienced human worker can move boxes at a similar rate, but not all day long, whereas Stretch can go for 16 hours before recharging. And this kind of work is punishing on the human body, especially when heavy boxes have to be moved from a near trailer ceiling or the floor. Labrador's deceptively simple home robot. It's not often that we see a home robot that manages to be both relatively affordable and realistically technologically achievable, while also solving a clear and widespread need. The iRobot Roomba was arguably the first good example of such a robot, but I'm hard-pressed to think of what the second good example might be, which is why this new home robot from Labrador Systems is so exciting. It's essentially a semi-autonomous mobile table, which poised to have a huge impact on people who could really use exactly that. If you're not sure why anyone would need a semi-autonomous mobile table, then congratulations on likely being young enough and healthy enough that you aren't currently experiencing significant mobility problems. But for many older adults, as well as adults with disabilities, reliance on mobility aids like canes or walkers means that moving around while carrying things in hands or arms is difficult and dangerous, and for some, moving at all can be painful or exhausting. This can necessitate getting in-home help or even having to leave your home completely, and this is the problem that Labrador wants to solve, or at least mitigate, with its mobile home robot. Robots and bubbles for underwater litter. Many people love to visit the seaside, whether to enjoy the physical benefits of an exhilarating swim or simply to relax on the beach and catch some sun. But these simple, life-affirming pleasures are easily ruined by the presence of litter, which, if persistent, can have a serious negative impact on both the local environment and the economy. If you happen to be around the coast of Dubrovnik, Croatia in September of 2021, you might have spotted 2 robots scouring the seafloor for debris. In this team of 2, one has been trained to recognize waste, the other to collect it in its basket. The robots were embarking on their inaugural mission and being tested in a real-world environment for the first time to gauge their ability to perform certain tasks such as recognizing garbage and maneuvering underwater. We think that our project is the first one that will collect underwater litter in an automatic way with robots, said Dr. Bart de Schutter, a professor at Delft University of Technology in the Netherlands and coordinator of the Sea Killer project. Robots, simplifying imitation learning. Over the past few decades, computer scientists have been trying to train robots to tackle a variety of tasks, including house chores and manufacturing processes. One of the most renowned strategies used to train robots on manual tasks is imitation learning. As suggested by its name, imitation learning entails teaching a robot how to do something using human demonstrations. While in some studies this training strategy achieved very promising results, it often requires a large and annotated datasets containing hundreds of videos where humans complete a given task. Researchers at New York University have recently developed VINN, an alternative imitation learning framework that does not necessarily require large training datasets. This new approach, presented in a paper pre-published on RZiv, works by decoupling 2 different aspects of imitation learning, namely learning a task's visual representations and the associated actions. Algorithm to avoid obstacles. If you've ever ordered a product from Amazon, chances are that a robot selected your purchase from a shelf, read the barcode, and delivered it to the counter for packaging. Hopefully, it didn't collide with a human worker on its journey and lose its way. The odds of that happening have now shortened, with University of South Australia researchers developing an algorithm to help robots avoid running into humans and other moving obstacles in their path. UniSA Mechatronics engineer lecturer Dr. Habib Habibullah and colleagues have built a computer model that ensures mobile robots can recognize and avoid unexpected obstacles, finding the quickest and safest path to their destination. With that, we end today's dose of our weekly updates. Join in next time for more of such exciting news happenings from the robotic world.